So once again, welcome back. So today we'll discuss about mobile wireless sensor networks. So usually, whatever the topics we discussed till now, that is about wireless sensor network. So we considered that as a stationary network. So as we discussed in the previous classes or previous lectures, there are two categories of networks are there. One is stationary network and second one is called dynamic networks. So in the case of stationary, as we discussed, there is no movement of the sensor node is allowed. As the sensors are deployed, so these nodes will not move around the network or within the network. Now, today we are going to discuss about some concepts of mobile wireless sensor networks. So in this, we are going to discuss what is mobile wireless sensor network, what are the components we have to establish the network, and what type of nodes we have, and what are the various paradigms of sensor networks and the delay tolerant network. These are the topics we are going to discuss today. So as we all know, just I want to repeat the things what we discussed in the last class. In the stationary wireless sensor network, we have some advantages as well as some disadvantages. So as the stationary is nothing but the node will not move in that particular network. So we have some advantages in this stationary wireless sensor network. They are, so when we deploy the nodes in the stationary network, let us assume we assume that the whatever the nodes we are deploying in the sensor network is stationary network or stationary nodes. So we are assuming that the stationary in that particular sensor network deployment very easy to deploy because simply we need to throw that corresponding nodes where we want to cover that particular region. Simply we need to throw, that is very easy to deploy. At the same time, these sensor nodes, when we want to make a network by using various sensor nodes, so we should have a plan to how we are going to deploy the network, or where these nodes has to be deployed. So these things we need to consider when we deploy the stationary network. At the same time, we are going to establish a physical network among the nodes. There is no virtual network here. Once the sensor nodes are deployed, that they themselves establishing the node by communicating the neighbor with the neighboring nodes. So due to this the physical topology of that particular network, these nodes will not change or does not change the location from one place to another place. So it is easy to manage as well as it is that corresponding network is easy to operate. So when we consider the placing of nodes at that case, when the node is trying to communicate with another node, we are considering that as a stationary sensor network, and which will be helped in the what we can call properly planning and optimizing the number of nodes that would be required in that particular region. That means, for example, if you want to cover 10 meters by 10 meter region, let us assume the capability of one sensor node is 1 meter. Let us assume that. So instead of deploying more number of nodes within 10 meters by 10 meter range, or instead of deploying very less limited number of nodes in 10 by 10 meter range, we should be that the number of nodes should be appropriate based on the distance we are going to cover. That means we need, when the nodes are deployed, we need to maintain the corresponding distances, appropriate distances between that corresponding nodes. As we said, it is stationary, we can easily maintain because once the network was established, once the nodes are deployed, then they are communicating with each other to establish that particular network. When the network is established, then the topology of that particular network will not change, and at the same time These networks are stationary sensor networks, as these are very easy to maintain as well as very easy to operate, as we said now. So there are some disadvantages are also there in the case of stationary network. Let us assume, as we said now, in 10 meters by 10 meter range, let us assume we deployed 10 sensors. Let us assume that. So among these 10 sensors, if any one particular node is failed, one or two nodes are failed in the 10 sensors, then the distance may vary from one sensor to another sensor. If the distance is varying, that means they cannot able to communicate with each other when the distance becomes more. So in that case, the network is going to be divided. As we can see from this slide, there are some sensor nodes. Among them, some sensor nodes are inside the range of that particular other node, and some are outside the range. So the outside range, the sensor nodes are marked with red color. We can see the red color sensor nodes are not covered under any one of these networks. As in between one node was failed, let us assume that in that case we cannot establish a single network with the deployed sensor nodes. So what happens in this case? So the network is going to be divided into multiple networks, multiple individual networks. So instead of here, we can see from this slide, there are three networks formed from the deployed sensors. So to make these three individual networks into one single network, what we need to do? We need to replace the failed node with the active node. So when the active node is deployed, so that the range becomes closer, so they can communicate with each other and they can form a single network, a single large size network. So due to this node failure, there may be a possibility of losing the data. Some data may be lost if any node is failed. At the same time, the whatever the information sensed by one particular node will not be delivered to other corresponding nodes, as the node which is intended to deliver the data, that is called destination node. So the data may not be reached to the corresponding destination node. So as it is stationary, once the node was deployed, as we discussed now, the topology will not change automatically. So if you want to change the topology, we need to have the human intervention when if you want to change the topology of that particular network. So what is the solution then? So instead of deploying the stationary sensor network, we have the problems of node failure. We have the problem of the topology will not change automatically based on our requirement. So the solution is, instead of deploying 100% sensor nodes or stationary sensor nodes, what we are going to do is we will make one or two sensor nodes as mobile sensor nodes. Mobile nodes. Mobile nodes means what? The node may change the location from one place to another place. So when we have a fully connected wireless sensor network with the nodes, as we said now, the red color nodes. So I want to combine these red color nodes into uh, uh, when I'm replacing this red color node with the active node, so that it will become one single network. So in such scenarios, like this example what we discussed, the entire network is partitioned into three networks because of node failure. So once the fail node is replaced with active node, then they can capable of establishing the reconnectivity, or the nodes will be reconnected to form one single network. So when we deploy some mobile sensor nodes, so that the topology becomes dynamic topology. So instead of static topology, we can say that dynamic topology, because always the topology is going to be modified. Always the topology is going to be changed as the node is moving from one location to another location. So in this case, due to the dynamic topology, or because of the movement of nodes from one location to another location, we can able to maintain the connectivity between the various nodes, so that we can, but indirectly we can improve the performance of that corresponding network. So these are the advantages as well as disadvantages of stationary wireless sensor networks. To overcome these disadvantages, we are going to replace any one or two nodes with mobile sensor nodes, so that the topology becomes the dynamic. So here all or some nodes are mobile in that particular network. We are combining the features of mobile ad hoc network. I think you know the concept of mobile ad hoc networks, right? So always the nodes are in mobility. So the nodes are shifting from one location to another location. So very frequently the topology is changing. Due to this change of topology, we need to have several criteria to establish that particular network. We'll discuss later. So as it is infrastructureless network, right? So there is no fixed infrastructure is required. So if suppose if I have one mobile and if I have one laptop and if I have one desktop or if I have one PDA, so all my personal belongings, the devices which belongs to me, I want to establish a network with all these devices. So without any fixed infrastructure, without depending on the physical infrastructure, it is possible to establish an ad hoc network. Ad hoc means temporary. So temporary network with all these devices, so that we can transfer the data from one device to another device. So the properties of the ad hoc network are, so these networks are having the capability to configure themselves. If any problem is occurred, they can have the capability to heal themselves, and based on the nodes we have or based on the distance we have from one node to another node, it is possible to optimize themselves, and they can have some security features. They can maintain their own security of in a particular wireless mobile ad hoc network. So in the case of wireless sensor network, so these based on the area we are going to cover, we need to deploy the sensor nodes in that particular area. If small area, small number of sensors; large area, large number of sensors; more number of sensors we need to have. So these nodes are capable of collaborating with one another, so that simply whatever the surrounding devices or whatever the neighboring devices are there, neighboring sensor devices are there, they can have the capability to communicate with them once the node was deployed. Here, mobile wireless sensor network is, we are combining the features of wireless sensor network as well as the mobile sensor network, that mobile ad hoc network. So these two features are combined into mobile wireless sensor network technology. So when we comes to components of mobile wireless sensor network, there are three major components are there. Like in other networks, here also we have three components are there. Among them, the first component is called mobile sensor node. So this mobile sensor node, in the sense, a sensor node itself, it is having the capability to sense the event to be occurred in surrounding area. So the mobile sensor node, in the sense, it is having the property of mobility, but when it is moving, or when a sync node or base station is moving towards it, when it is coming into that particular region, means it will sense the data, right? So when these nodes are coming close to that particular sync node, then these mobile sensor nodes are capable of sensing that particular data. In the case of sync node, simply it will move around the network, to collect that particular information which is sensed by the sensor node. And here one new concept, these two are common in any network, but one new component which we can see in the components of mobile wireless sensor network, that is called data mule. So mule in the sense, it is like a sensor node, but the job of this mule is to move around that particular network, and wherever the data gathered by sensor node, that data will be collected and the data will be delivered to the sync node. There are three components. One is sensor node, which can have the property of mobility, and the second one is sync node, which is also having the property of mobility, and the third one is called data mule. The sensor node, which will sense when it reaches to the area or the reachable to sync node, when it reaches to, when it is shifted or moved to the sync node region, then it will sense the data. The sync node is simply, it will go to one particular node, it will collect the data and transfer it back, and again it going to another node, it will to collect the data. And data mule is nothing but, it is just like it will work as a transformer. That means it will go to one particular node, it will collect the data, then the collected data will be transferred to the sync node. Likewise, these data conversations we can see from this slide. So in the first image, there are four nodes are there, and in the virtual communication range, we have a sync node. That means what? From we have a dotted circle. So inside dotted circle there are two nodes are there. Outside dotted circle there are two nodes again. So when that means the sensor nodes which are inside the dotted circle are reachable to the sync node or virtual communication range. So these two nodes will transfer the data to the sync node. Now later the sync node is shifting towards another node to collect the data. Again the sync node is shifting towards another node to collect the data. Likewise. So these are the three main components of this mobile wireless sensor networks. So what we are doing is, in wireless sensor network, we are introducing the concept of mobility, so that it is not necessary to maintain or to deploy all the mobile sensor nodes itself. So in a particular network, we are going to deploy one or two mobile sensor nodes so that they can move towards the node which is not having the connectivity with other nodes. So when the mobile wireless node is reaches to the sync towards it is traveling towards the sync node, when it reaches to virtual communication range, then the data communication will take place. At the same time, whatever the data sensed by these different individual nodes, they can be transferred to the destination node, that is called sync node, or even if we have when this concept will be used when we have a very limited number of nodes deployed in that particular region. Next, when let us assume that all the individual nodes are stationary nodes and we are deploying the sync node with the concept of mobility. That means when we have mobile sync node, this mobile sync node is going towards physically going to the close, we can say that close proximity of each and every these stationary nodes which are in red color, and then it will collect the data from these red color nodes, and the collected data will be transferred to stored in the sync node itself, because the sync node is only moving from one location to another location. So now the sync node goes to another sensor node and get the data, and again move to the next sensor node, it will continue like this until all the sync node is going to be collected all the information from the remaining the sensor nodes. So when we comes to types of mobile wireless sensor network, so there are three kinds of mobile sensor networks are there. That is underwater, and which can be where it is possible to deploy the nodes under the sea, as we discussed in the last previous lecture, the application of wireless sensor network. Here also the mobile wireless sensor network is also possible to establish underwater, and terrestrial means which can be deployed on land surface, aerial means which can be deployed in the air. So when we comes to underwater mobile wireless sensor networks, so in these networks, what is going to be happen? Basically, when we deploy the sensor nodes in underwater, there are two kinds of nodes which it is possible to deploy. One is called active node, and the second one is called passive node. So active node means they can be actively, or we can say that intentionally want to move from one place to another place, and the second one is called passive mobility. So passive means intentionally these nodes will not move from one place to another place, but due to the we can say that these nodes are floating nodes, because there could be different ocean waves. Let us assume if the network is established under in ocean, so because of ocean waves or some other activities which are performed under the sea, these waves will hit the particular nodes, so that these nodes are going to be displaced from their original position. So these floating nodes maybe transfer the data, just like as we said now, autonomous underwater vehicles, the vehicles which are traveled inside the water and they are managed autonomously. There is no human intervention is required. So everything will be done according to pre-processed program. So these autonomous underwater vehicles will act as a mobile sensor node to sense the data, and which will be transferred the data to other sensor nodes. And by combining all these autonomous underwater vehicles or the other sensor nodes, active nodes or passive nodes, so will all these combinedly form underwater mobile sensor network. So usually these networks have different applications, like covering or monitoring marine life, or simply tracking the quality of the water of that particular part of the ocean where these nodes are deployed. It is also possible to have one more application called surveillance, uh, which can be monitoring based on the where we deployed that particular sensor node. So we need to monitor the surrounding places for changes to be occurred in that particular area. So when we comes to second one, terrestrial mobile wireless sensor networks, which can be deployed on land surface, So when these nodes are deployed in land surface, uh, we can simply call it as robotic devices. So because of these robotic devices, which would be moving from one location to another location to collect the data or to transfer the data, depending on the role of that particular node. So the overall communication is going to be uh, performed based on the distance we are maintaining between two sensor nodes. So we can link, let us assume that we have one mobile, and mobile is also having various sensor devices to sense the various activities. So when we are moving from one location to another location, by default the sensor is also moving. Likewise, so when the nodes are deployed, so we can have the movement. So as we discussed in the previous lectures, again there are applications like wildlife monitoring, as well as the surveillance and object tracking. If you want to track any at the movement of one particular uh, animal, or if you want to track the particular movement of one person, it is possible to track by using these terrestrial mobile wireless sensor networks. In the case of aerial, in the air we are going to establish the sensor network, but it is not possible to deploy the sensor network in the air. Because of this, what we are going to do is what we are going to do is simply these these sensors will be moved from one location to another location with the help of, yeah. So with the help of other autonomous vehicles, so we can call it as unnamed aerial vehicles. So the one sensor node is attached to this particular vehicle so that they can move from one place to another place. So the applications which can be deployed with the help of aerial mobile wireless sensor networks are which can be used for surveillance, multimedia, as well as data gathering. Now, what are the possible entities which can be acted as the mobile node? So there are three things. One is called human entity, and the second one is called vehicle entity, and the third one is called mobile robot. So human entity in the sense the human is going to be acted as a sensor, and vehicle event is nothing but the one of the vehicle is going to be acted as a sensor. Mobile robot means our mobile is going to be acted as a sensor. So when we comes to human entity, so we can easily understand the mobility due to humans. We are integrating the concept of mobility due to humans. That means the human can sense themselves, and it could be using the mobile phones which have the individual sensors. So because of these mobility of humans, we may have the mobile sensor node which is a human being. That means we are considering a human as a sensor node. So this concept, the considering human as a sensor, is called human centric sensing, that we'll discuss now. So these mobile human beings which are acting like a sensor node, and they are going to sense and also going to move the data as well as the node from one location to another location. So when we comes to vehicles, we can treat the vehicle is also mobile. So if we have sensor fitted to these particular vehicles, any one of these vehicles, because the vehicle is going to be moved from one location to another location, so along with the vehicle, these sensors are also going to be moved from one place to another place. So these mobile sensors in these vehicles are going to sense the different data for which the purpose they are going to deploy it, and then data is going to be sent to the base station, or simply in the case of vehicular ad hoc network, we can call it as roadside unit. As these sensors are deployed or fitted with the vehicles, so this network is going to be formed as vehicular ad hoc network. So, like other sensor networks, this in vehicular ad hoc network, the sensed data is going to be transferred to the base station in the case of sensor network, and the base station can be represented as roadside unit in vehicular ad hoc network. So, the sensor nodes which are deployed or which are fitted with the vehicles will be trying to communicate with its base station called roadside unit. And the third entity, the possible entity is called mobile robot. So this mobile robot is one type of just like a mobile device which can be used this mobile sensor node like what we discussed in human entity. We can be these mobile sensor nodes can be like human beings. So when a human is moving from one location to another location, along with the human, the corresponding device is also moving from one location to another location. Moving to one location to another location. So, because of this mobility, this mobile robot concept makes us the one among the entities that could be used for mobility of nodes in this particular network. So when we comes to human centric sensing, so as we discussed, the human is going to sense the environment and the sensed environment is going to be transferred from one location to another location. So again, this is divided into three categories, that is three ways. The human is going to sense the environment in three ways called participatory sensing, people centric sensing, and the opportunistic sensing. So in this sensing, we have the three distinct roles are there. One is called sensing target, one is called sensor operators, and data source. So sensing target in the sense what the sensor is going to be sensed, for what purpose we deploy it. For example, if you want to if you are deploying a sensor to sense the temperature from the environment, so it will do that particular event itself. And if you deploy the sensor for other purpose, the purpose has to be solved by that particular deployed sensor. So sensing target in the sense for what purpose we deployed a sensor, that is called the sensing target. So the sensor has to play a role to sense that particular target. And the sensor operators, so which can be indirectly running behind that particular human intervention. That means let us assume that our mobiles are having various applications. So these applications are internally connected with the sensor, so that once the sensing was done, the signal was sent to this particular application. On that application, we can see what the sensor has sensed, like the temperature, or like the weather condition, or like, so if you have an application to count how many steps how many kilometers you are walking per day. That means there is one application, we can install third party application into our mobile. So when we are working with our mobile, it will simply count. That means what? There is a sensor which will sense our body movement. So with that body, once the sensor was sensed that body movement, it will give signal to that corresponding application so that the data will be updated. So data source in the sense from where these sensors are going to be get the data, from where these sensors are going to gather the information to disseminate. So the basic idea of this particular human centric sensing is the humans has to carry the devices or they can move around that particular sensors. And the job of the sensors which are embedded into that particular device will record that corresponding readings, and the readings which are sensed by sensor node will be transmitted. We have also challenges like other networks, like energy of device, the battery backup of that particular devices, and participant selection. We need to select which node to transfer, which node to receive, and which nodes to integrate into that particular network. Anyway, privacy is also one of the challenge. So when we can simply, by this we can simply understand that when we are talking about humans as a sensor node, the privacy becomes very big challenge, because we cannot estimate the attitude of a human. Let us assume that there is one source and there is one destination. If the source and destinations are in reachable area, they can directly communicate with each other. But if they are not in the communication area, they has to depend on the intermediate nodes. Likewise, if you depend on the intermediate nodes, here the intermediate nodes are also human. Let us assume that in human centric routing, the intermediate nodes are also humans, then the privacy becomes very important issue in this case. So the whatever the sensed information from human being is going to be uh, transferred to the corresponding destination or the sync node. Again, the sync node is also the human. So in this case, we cannot predict the attitude of that particular human. He may reveal the information which is going to be transmitted, or he may modify that corresponding information which is going to be transmitted. So in this case, the privacy is becoming very important issue. So here, when we comes to the first one, the participatory sensing, we can observe from this slide there are various servers and database servers, and there is web service. There are so many participants. The cluster, we have a cluster, and we have a sensor network, and we have a user. Here we can observe, here it is a participant. That means the participant sensing is, if I am interested to participate in the communication, if I was interested to communicate with other nodes in that particular network, then we can call it as participatory sensing. That means if you are able to participate in the network, then only you are going to get the sensed data. Even though if you are in the same region, communication region, if you are not willing to participate, then if you are not allowed to participate in the network, even you are not going to get any information which is transmitted by other nodes. So this is the initiated in the year 2006 by the researcher called Burke. The Burke initiated this participatory sensing in the year 2006, but the basic idea of this participatory sensing is the the nodes has to be deployed in distributed manner, and these devices has to be carried by the humans. The human only carried that particular device. The basic idea is to just collect the data, but this collected data will be available to all common people to access as well as to share the corresponding knowledge. So let us assume, let us discuss one simple example. So the participatory sensing will collect you can say that the quantitative information. The quantitative information in the sense, for example, we have a sensor. That particular sensor I deployed to measure the oxygen levels in that particular region, or the oxygen levels of that particular air in the deployed region. Now, the job of the sensor is to simply it it has to wait, or it has to sense that particular environment very regularly. Then I developed one application, third party application, which will be interconnected with that corresponding sensor node. So when the sensor sends that application, sends that environment, immediately the sensed environment outcome, that is the gathered information which is gathered by that particular sensor, will be disseminated to the application. So from that application, we can easily see the oxygen level of that particular location. But here, the thing is, when if we have only one single node, there is no problem. But if we deployed multiple nodes to measure the oxygen levels of that particular region, let us assume that. So what is going to be happen? All these nodes are gathered the information, or gathered the information about the oxygen levels of that region, and they are communicated with each other. When they are communicating with each other, the the information collected by one sensor will be transferred to other sensor, and the information collected by second sensor will connected to remaining communicated with remaining all the sensors. So in this case, it is not possible to get the exact, that is from where the data came, from where the oxygen levels, the information will be received. So in this case, what is going to happen is each and every node is going to be going to have authenticity. So how to provide authenticity of that particular node? That means we need to integrate that particular sensor with one particular identity. By integrating with the GPS, or by integrating the node with geotagged, that geotagged information has to be retrieved, because there is no point of getting oxygen level information if you don't know the exact geographical location. If it doesn't know the location from where we are getting the information, there is no use of deploying the sensor. So by this, we can by attaching the geotagged information, so that the sensor will disseminate the data along with the geotagged information. So we can easily identify from where this data was disseminated. That means the in human centric routing, the participatory sensing will has to provide the quantitative information along with the authenticity. The quantitative information has to be provided. And the second category of human centric routing is people centric sensing. That means people are sensing themselves about the surroundings. So here we can see, we can have the personal sensing, we can have the public sensing, and we can have the social sensing. So in this case, so in people centric sensing system, again the humans are acting as a sensor node. Instead of using some animal, or instead of using some other living things, the human is going to be acting as a sensor. So for the benefit of the common citizens, these people centric sensing is used here generally. So what it has to do according to this, which will enable the sensing coverage where the large public was roaming around. So what it has to do, where the more number of people are roaming, from them it has to collect the information, and that will be transferred to the sync node. So the sensing coverage of spaces where the more number of people are roaming, or when an events are occurred, when any functions are going on, or any large number of human interactions are going on. In that case, these people-centric sensing will be used. So, in this, the sensing devices has to be carried by the public itself. The sensing device may be attached to a mobile or some any other device which we carrying. So it will create this people-centric system. Will create a symbolic relationship between the communities as well as individuals where we are roaming. One example for people-centric routing is MetroSense. We can see. So it was initially proposed by Campbell in 2006. So which is one best example for people-centric sensing system. Here, two things we need to have. One is called uncontrolled and second one is called controlled. So uncontrolled means there is no pre-programmed. That means if any device, if any sensor is deployed or if any sensor is attached to human being, we don't know after 10 minutes that particular human being where he is going or where he is moving or where he is available after 10 minutes, right? So the movement is dynamic. Prior to now, we cannot say after 10 minutes where he is going to reach or where he is going to available. At the same time, if you attach like ZebraNet, what we discussed in the previous lecture, ZebraNet, simply they will attach sensor to zebras so that they will track the movement of zebra, but they don't know after in future time at particular point of time these zebras where they are available. In the case of controlled, so in controlled, everything is pre-planned. According to the planning, the nodes has to be moved from one location to another location. So this is one MetroSense project they initially used for pre-planning as well as planned things. But in this, there are two things or two stages of that particular project. One is called in the first stage, they have to sense, and the second stage, they have to learn. Simply, they have to gather the information and they need to analyze. That analysis has to be transferred to the neighboring nodes. And the second is called opportunistic sensing. So, in this, we'll use a sensor devices and we'll treat these particular sensor devices as low priority as well as the secondary devices. Will not consider the sensors as the main criteria. Deploying sensors is not a main criteria. We'll consider the sensors as secondary devices and we are giving not that much priority for the sensors, but we are giving the priority for the movement of people. So in opportunistic sensing, whatever the controlled approach or whatever the decision making approach will give to the secondary system, that is we deploy once the nodes were deployed on the humans, we are going to integrate with the one application. So that application is going to monitor our movement of human beings from one location to another location. Let us assume that if we consider Google Map, once we registered with our email ID, so Google Map will store the location where you are moving from one place to another place, and they will give report to you. They will send one report to your mail ID by stating last week where you are, this week where you are, and the travel history, it is going to be uh, sent to our the registered mail IDs. And the next topic we are going to discuss is delay tolerant networks. I think everybody knows this one. In early stage, delay tolerant network means delay means some amount of time is required to transfer the information from one node to another node. That may be 1 second, or that may be 1 millisecond, or that may be 1 minute. Based on the distance, some delay has to be uh, there, some delay has to be occurred to transfer the information from one node to another node. Tolerant means the network what we are going to design, or the network what we are going to deploy, that network is having the capability to tolerate the delay. Tolerate the delay. So, for example, if we consider some streaming application, multimedia application, let us assume, or YouTube, if you consider, when we are trying to open one video, immediately it will not play. There is a buffering time. So, there was a delay and there was a buffering time. So, the delay is the time to reach the multimedia data from source to your system, destination system. And buffering time, once the streaming was initiated, the user should not feel the bore, or user should not consider that as a uh, wasting of time. So for that case, it will provide some buffering so that the data, multimedia data which is transferred from the source system will be stored in the buffer. So after certain period, it will start streaming. So the DTA network will able to tolerate that particular delay. Usually when the delay is happen when the heterogeneous networks are connected. Various categories of networks are connected, usually the delay becomes more because the data has to be converted so many times when the data is transmitting from one network to another network. If two systems, source and destinations, are in the same network, then the delay may be less. If the source is one category of network we have and destination is available in the second category of network, in this case, when the data is transmitting from one network to another network, usually the delay becomes more. So, before the DTR network is designed by assuming that there is an ND to ND2 connectivity, assured connectivity, and there is very less and short delay, and the data rates are symmetric, that is, the fixed data rates, the error rates are very low. These are the assumptions when they designed DTN network. And we can see here above LAN or metropolitan area network or core network, there are the various events to be performed on the DTN, like instant messaging, collaborating the various kinds of networks, email delivery, telephonic, video conferencing, and chat rooms. But once the DTN networks are initiated, along with the previous facilities, the users are going to be expected the other facilities like called IPTV as well as online streaming. So in this case, we cannot restrict these DTN networks to the same category of network. So day by day, the day-to-day life or whatever the things we are using in our daily life, there is a rapid developing or there is a rapid increasing number of devices or physical devices are connected to the internet. So now in this case, we can have various kinds of architectures and various kinds of network protocols and various kinds of the network topology. So when we are connecting all these various kinds heterogeneous networks, one network is using one category of protocol, second network is using other category of protocol, like this. So the communication is not limited here. In this case, the delay tolerant DTN networks has to be used. So now the thing is how we are going to connect or how we are going to integrate the various kinds of networks. How we are going to integrate heterogeneous networks. So when we are integrating the heterogeneous networks, we need to consider the node constraints and mobility of that particular node and end-to-end connectivity. In the case of delay tolerant network, there is no guarantee of end-to-end connectivity. When we compared with the other nodes, the DTN network is having the error prone percentage is more, and based on the category of network, the delay may vary from one connection to another connection. Some examples of DTN, we can have the vehicular ad hoc network. In this, the darknet is one example, message ferry is one example, village network is one example. So darknet in the sense, it is a kind of mobile device which will be connected to integrated to a vehicle. So what it has to do is simply it will go to one particular region or it will go to one particular node. It will collect the data just like a data mule, and the data will be disseminated to the sync node. Okay. Likewise, in mule networks also, ZebraNet and carrier pigeons. ZebraNet, what we discussed in the previous lecture, simply to track the movement of zebra, ZebraNet is used. Carrier pigeons in the sense, in some sensible areas like military and other defense areas, to transfer the information, simply they used instead of using technology, they used pigeons to carry their information from one location to another location. So here in DTN, we can simply call this as D star network. That is, three Ds are there. One is delay, and second one is called there is no end-to-end connection. So we can call there is no guaranteed end-to-end connection. So we can call this as disconnection and disruption. Disruption, delay, disconnection. That means when we are usually when there is an end-to-end guaranteed connection, that means we are transferring the data with the help of TCP. So when the TCP connection lost, when the delay becomes more, what it has to do? It has to retransmit the packet and again. So when the TCP IP breaks or when it turns to delay and disruption, then we are going to DTN network. So the another examples of network DTN network are, we can say that interplanetary networks. Now we are establishing communication among the networks on the Earth, but now the researches are going on interplanetary network. We can call this as deep space network. We are going to establish a network from one planet to another planet. So we can call this as deep space network. Still, the research is going on this network. Underwater networks and military networks. These are the other examples of DTN. Now, when the various categories of networks are interconnected to form DTN, here we can see DTN1, DTN2 and DTN3 which are interconnected with the internet. But here the dark circle A and B are connected to the internet and G and H, K are not connected. So we can call this as isolated regions. So in this case, to make it connected or to make it active node, we can have the DTN network. When we comes to protocol stack, so usually we can treat this as a packet which can be used in transport layer. But in DTN network, instead of calling that packet, we can call this as a bundle, right? So we can the concept is same, but instead of calling packet, we can call this as a bundle in DTN network. The number of layers are same. As we know, in OSI layer, we can have any number of layers based on our requirement. And here, the remaining concept is same. When we are transmitting the information from one node to another node, with along with the intermediary node, or you can call this as a router. So in each and every layer, the corresponding information will be added to the header or footer, and then it will be extracted in the respective layers. Again, it will be added like that. It will transferred from one node to another node. So usually these DTN networks are, as we discussed now, there is a lack of end-to-end communication path. At the same time, the latency is very high in the case of DTN networks. And the same time, based on the protocol you are using in the one particular network, or based on the varying of usage of protocols in various networks, we can whatever the communication channel we are using, that communication channel is having asymmetric data rates. That is, there is no common data rate. We have a different data rates based on the protocol and based on the topology of that particular network. So as we discussed now, in DTN network, the error prone rate is very high, and the when we comes to DTN architecture, the goals are the network has to tolerate the delay and the network has to tolerate the disconnection rate. Because of this, we have high loss and high delay, high error prone environments. So we should have the interconnection among the various kinds of networks. That is the main goals, and these are the components we already discussed here. We have a flexible naming scheme. We can name any device by allocating the corresponding IP or some domain name we can allocate. And we have the message abstraction and API. It is possible to integrate with the applications. When we comes to the routing, we have two categories of routings are there in DTN. One is called proactive and second one is called reactive. So in proactive means the basic difference between proactive and reactive is proactive. That means before initiating the communication, everything is known to that corresponding source node as well as the destination node. Before initiating the communication, the source and destination are knows everything. That is the communication path, what are the intermediate nodes, everything it has to know. The examples are DSDV, destination sequence distance vector, and OLSR. These two are the proactive routing algorithms in mobile ad hoc network. In the case of reactive means, it will not, before initiation, it will not do anything. Before initiation, it will not do anything. So once the request came, once the broadcasted request is received by the neighboring node, what it has to do? It will, at the time, it will check. It will check what are the intermediate nodes and from which path, the path which is going to be selected to transmit the information like that. So proactive and reactive. So with whatever the intermediate nodes or whatever the routers we have, that routers will form overlay network. That routers will form the overlay network. That means only selected or the configured nodes are participate. It will not, the every node is not going to be participate in this particular network. Simply the selected are the configured nodes. The nodes which are selected to disseminate the information, only that nodes will be participated in that communication process. So this DTN routing topology is, we can call this as a time varying multigraph. That means the links will come and go, or sometimes periodically the links will be activated. So it will use, uh, it may use all the links, or it may use some of the links to disseminate the information. So the messages, based on the size of message, the message will be fragmented. These are the concepts we have in DTN routing. So in this also we have some routing problem. So from this slide we can see we have an internet in the city and we have the internet in the village. When we are moving from one place to another place, there is some one particular point where the communication range is not reachable to this network or to the second network. So in that case, we have to use the other methodologies, like to satisfy uh, the transmission of that particular demanded message, or we need to maintain the buffer limits, or we need to prepare one graph with vertices and as well as edges, or some metrics we need to frame to deliver the message in that particular scenario. So this is all about the mobile wireless sensor network. So here some scope of research in the following topics. We have IoT and reliable and energy efficient transport protocol, and efficient approach to restore the connectivity in wireless, and still there is a scope in naming as well as addressing in delay tolerant networks, and partial scheduling, multicasting, multi-layer survivability, and integrating GPS with DTN. These are the various topics which we are going to have.